Hey everyone, thanks for joining the webinar today on the future of QA. This is Izzy Azari. I'm joined by the legendary Ed Rousseau, a man who needs no introduction, I will say, but I'll introduce him by his Twitter profile. How's that, Ed? So, international gentleman of leisure, breaker of software, and utterer of awkward questions. So I look forward to the discussion. For the audience, we will be doing a Q&A at the end, so feel free to add questions, and we'll answer those questions at the end of the webinar. Thanks a lot.
All right. Hello, everyone. The name of this talk is The Future of QA is Now, and let's get started. A little bit about me. I've been in the tech game for maybe, just over 20 years. I've been all over the IT shop, QA engineer. I've been a product owner, an actual manager, DevOps engineer at a number of different companies, some in the enterprise, Rockwell Automation or IQVIA. Did a long stint at Red Hat, some startups, Simply Safe there. I really am passionate about efficient engineering processes. I love Kanban, so it's all about flow. And the opinions on this talk are going to be mine and mine alone, and not representative of employers past, present, or even future. So for my personal journey, I started tech in the mid-90s at Rockwell Software, and I started in tech support, so I had a frontline view on seeing problems. And as these problems mounted, I actually got to be ground floor on a QA initiative. So that was really taking a buggy Windows 16-bit app and trying to get have quality in the Windows 95 version of that app. So yeah, that kind of dates me a little bit, but I did say I've been doing this for a while. Yeah, some of the other places in tech stacks I've worked with, a startup that did Java AI around the millennium, bots before, really all that machine learning was really there yet, so that lasted for a bit. Worked for a CDN, a content delivery network, not called Akamai, so that gave me some good insight into some internet stuff. My time at Red Hat was initially as the desktop QA lead, so back in the times where we had to test the X server and about 50% of the distro by code count with about 3 people. That's how it started, and build that team out. Around the RHEL 5 days, I was the QA manager for that, so for anyone who actually had to use that, I'm sorry. I like to think I did a good job because it stuck around for so long. My last bit of time at Red Hat, really, I did a pivot to really look at infrastructure and how Red Hat did their release tooling. So that was all owned by QA back in the day. So when that pivoted out into its own group, I went with that, and I was the product owner there for, I think most interestingly, the Beaker project. That's still alive today, and that's what Red Hat uses to test all the different hardware in distributed labs. So that is kind of interesting. I did some stuff at Simply Safe with embedded in IoT because they're a alarm company. Helped do the firmware testing and get the QA around their internet-enabled camera to market, and really worked hand in glove with the DevOps team there for that. And presently, I'm at IQVIA, which is a large clinical research organization. We like to call ourselves the Human Data Science Company. So we do that in the cloud. All right, so what are we doing here today? So I have 3 kind of main points in this talk for takeaway. The first is that today's CI/CD cloud-native world really has killed what we think of as traditional QA and testing in organizations. And if it hasn't happened in your organization, it is right to happen in your organization as these techniques are embraced and brought forward. The second is that infrastructure code, so infrastructure as code, actually needs more testing than product code. And I'll get into a few reasons why I believe that's true. And thirdly, that in this kind of new infrastructure as code, CI/CD, traditional death of QA world, a QA mindset is still very, very relevant. So I want to take a little step back and kind of define what I mean when I talk about QA people or a QA mindset or a testing mindset. In the book Beautiful Testing, there's a great chapter by Linda Wilkinson called What's It Good For You? And it really kind of goes through and describes kind of the personality traits and quirks and background of people who do test, people who do QA. So from that, we can glean, okay, what is a tester? What is a QA person? Well, most of us have this kind of macabre sense of humor. It's because we like things when they're broken, right? You know, the best days of my life as a tester has been finding something that is a seg fault or you know, sev one kind of thing. It makes me laugh with evil glee. Testers and QA folk are curious by nature. They want to know if something is broken, why is this broken? So we'll go digging and try to see what exactly is happening to cause this particular behavior that we're observing. Experimental is a big one. Trying to find new and fun ways to break software. Quick learning, new features, new frameworks, new things coming over the wall at test and QA folk mean we have to be able to pick up things very quickly and adapt. Generally, we're also pretty apolitical. We like to stay in the realm of fact, mostly saying, you said this worked and it doesn't work, and not really get caught up in like, oh my God, we need to ship this because X, Y, and Z. You know, the business is on the line, or we'll miss a, you know, we'll disappoint a important customer or something like that. But most of all, the mindset, you question everything. You know, you don't take anything at face value. So if somebody asserts that, hey, you know, this is good, this works, we can just push this out to production, you're like, no. Let me at it for 5 minutes, and I believe that I can prove that that is not true. So time for a little bit of a history lesson, all right? So back in the 90s when I started, this is kind of your traditional QA waterfall kind of scenario. So basically, you know, I think folks listening to might have had this experience or at least heard about it. You get code thrown over the wall at you, right? So you have no idea how this stuff was made, and it just lands on you, and you're expected to actually, you know, do something with it, usually with less time than you were promised. QA, really, the view in the organization is less than development. You're kind of maybe a roadblock, a necessary evil, or something like that. It's like, no, the developers are king, and you are kind of the plebs that do all the work. Back in those days, there wasn't a huge amount of automation. A lot of stuff from, you know, lots of spreadsheet work, maybe some custom developed tools. In the early days, you had things like tools like Windrunner from Mercury Interactive, or like SQA Robot, before all these companies were bought by other companies and bought by other companies and sucked up into enterprises. One of the important things of the rollback then was QA really was kind of the proxy for the customer inside the engineering organization. And this was because it was, you know, this is pre-Agile, so it's like you might get some customers on an early release or beta for your product, but there wasn't really a good built-in mechanism to get customer feedback back into the engineering team. So QA had to have more of a system view on the product and proxy customers, and would work a lot with customer support to generate these kinds of scenarios and that kind of mindset. So what isn't QA's job? Engineering organizations from beyond time really have had kind of misnomers on what the role of QA is. You know, quality police, release pope, some sort of gatekeeper, or quality insurance, right? So that you're the ones that make sure that the release ships without defects. Right. So, but that's not really true. Most QA departments or testers don't have arrest powers. You know, they don't have badges. They don't kick down doors and say, "Stop, QA police! This cannot ship." Release pope. There's no blessing of the release. It's not something you want your test or QA department to do, because they usually don't have the full business context on whether or not this thing should go out. You know, and you can't test quality into a release. All you can do is point out where the defects are. So putting it on your testers or your QA department to have the responsibility of the release to ship without defects is completely unfair. So if that's not QA's job, right, or test job, what is QA's job? The way I think of it is the job is to inform the business of the state of the product in order for the business to make intelligent business decisions. So really, they're purveyors of information. What do? We do this by designing and running tests and experiments, analyzing those results, and giving an interpretation, and provide that information in a consumable way back to the business. One of the important roles is being a professional skeptic, is really to fight confirmation bias in the engineering organization. Now, this is super important because you can get all sorts of groupthink happening over time on roles about, you know, what the software is, what the software does, and what's important. And it's useful to have a role to say, whoa, wait a minute, can we look at those assumptions? Are those assumptions true now? I know we thought that back at the beginning of the project, but is that true now? So at the time, the biggest thing to defend against was, is mean time between failure, right? So, how long can we keep this thing from failing? So why is that? Well, if you think, the cost of failure was really, really high. You had long feedback cycles, so rework was expensive. You might have 4, 6 weeks, months to go back and look at a code base to fix a bug that has been reported. By that time, your developers are in a completely different mindset. You had physical product and inventory you had to deal with. Things were shipped on CDs, and before that, floppies. They had to go in mail or shipping carriers. You had logistics to worry about. You had paper printed manuals, translations of those manuals and documentation. So if there were errors in those things, you would have to actually destroy physical product, reship these things out, stage them for logistics, and reship them back to a customer. That customer proxy piece for QA is really, QA was there to break things inside so the customer didn't have to, and you didn't have to incur all this cost of rework on failure. So moving along, there was a little thing called the Agile Manifesto, kind of revolutionized how people thought about making software, and that coincided well with a lot of the push for online distribution, right? So instead of shipping physical products, you had downloads. So with the rise of the web, that was like really important. What we're talking about here, also at the same time, you had a big increase in test automation frameworks. There were a lot more that you could start to use, and applicable to many different software types. So on this kind of thing, Scrum of the Agile frameworks was the one that was the most well adopted. So what happened there is like, okay, QA person, you're on the Scrum team, and you're the one that writes all the tests. It's like, okay, and at that time it's like, okay, maybe you're running it in Cucumber or Gherkin or something like that, and you're the one that's responsible for all that. But you're on the team, you're on the engineering team. Or maybe you're doing some Selenium work or JMeter work or whatever. At the same time too, folks said, oh, we can just outsource this, right? There's a lot, with better communication, there was a lot of places that rose up and said, oh, hey, we can do it cheaper. So that happened a lot. And built into Agile, in Scrum practices, the customer engagement through things like user acceptance testing and things like that really kind of brought the customer in more to the engineering team by design. So with all of these things happening, kind of some of the traditional roles of QA as customer proxy, as the group that had the complete system view, really starts to erode. At the same time, this is how you get the kind of rise of operations and ops work in DevOps. It comes out of the back office, and the actual platform that you're on is part of the product. So your web presence, or your e-commerce site, or that is exponentially more important to the business. So the people that keep that running and available are now exponentially more important to the business. At this time, it's like, okay, great, we need to be fast. We need to start to get this out here. It's easier to ship things because we just have to update a website rather than like burning this golden master and sending it off to production, or building all these physical things. So the perceived need to be safer kind of drops off. Meantime between failure is no longer the name of the game. What is meantime to remediation, MTTR. Yes. How fast can I get that fixed? The cost of failure is super low compared to the old days. The rework is cheap, and that feedback is baked into the process. So the guardrails you need to guard against failure becomes low, and the results of a failure also become a lot less costly. So at the same time, with all this automation that's happening, it came down to a focus that in a lot of places that test automation was the only value that a test or QA group could give, right? So that they're thinking, okay, right, you're the folks that do Cucumber, you're the folks that do Selenium, you're the folks that do JMeter. So the great idea came, it's like, wait, if that's just coding, why don't we just let the developers do all the coding? That'll reduce our overhead. Right, okay, and then testers started to kind of internalize that, and that's kind of, in my opinion, one of the big tragedies of this era is to say, oh yeah, that's what our job is supposed to be. Our job is supposed to be just writing test automation. So naturally, the footprint of QA in organizations gets reduced even further. That actually is a dangerous thing. Having developers do test work and owning test work actually has a number of prerequisites. And like at the beginning, really good unit testing practices weren't all that widespread, right? So if you wanted to liquidate your entire, let's say, QA department and let the devs do it, there's a bunch of skills your developers need. Those skills weren't really taught or prevalent across the entire kind of developer community. Sure, you had really good developers or some, unicorn companies that really adhere to these things. The smaller shops that really kind of embraced Agile heavily and wholeheartedly, from the devs to test all the way up through management. But with a number of stories over the years of Agile failures or fragile or Agile fall, where things will be half implemented, just kind of liquidating your test department if you haven't really fully implemented that, it doesn't make a lot of sense. There's also the thing about misaligned incentives. So when projects get crunched, developers usually are rewarded for actually writing code and shipping code into production. So if they're also supposed to be the backstop, for quality, for test, they're not incented to, pull the ripcord, to break glass in emergency to actually make that stand. So there's a cultural component there too. Only if your corporate culture actually enabled the developers to be okay to say, stop, this is not good enough quality, would this actually work? Again, a lot of the CS schooling, defect prevention techniques there weren't really, focused on and drilled in and trained. The people that did this kind of came onto it through tribal knowledge. They learned it from other developers or folks that knew it, or they worked in a space where the consequences of failure were high. Thinking about embedded systems at that point, where you have a number of limitations, and that cost of rework still is high. So those would be good. And the last reason is continuous integration systems, like that Jenkins or something that would cruise control, things like that back in the day, that would help developers in unit test execution or be plugins for things like static code analysis and things like that. Organizations thought, okay, wait, we're doing CI because we have Jenkins, or we're doing CI because we have cruise control, and we have some unit tests that run, and that's not necessarily the case, because a lot of folks and a lot of places I've seen, I'm sure other people have seen it too, is what happens when those unit tests start failing? They turn them off, and that goes on and goes up. Further disruption happens with the rise of public cloud. This major paradigm shift in the industry. Right, so it really kind of came out of your unicorn companies solving their own problems, right? Your Googles, your Amazons, your Netflix, your Etsy's. They have a specific business problem that they have to solve. So that spurs kind of the initial patterns in cloud computing, and what those look like. Your established players in the industry totally get disrupted. Like how where's Blockbuster now? Right? So what's acceptable for delivery and what's acceptable for speed completely changes. Like time to market is king, right? Get that new feature out there. We need to have this now. We can't afford these long release cycles. We can't afford downtime, At the same time, you have this explosion of things in deployment automation, making things really fast and easy to release. So at this time, in the back office for our ops brethren, operational expertise is absolutely critical to the business, right? So the pipeline itself, the pipeline that delivers the thing out to the customer, is part of the product. Repeatable and reliable delivery, being able to turn that crank and get that next update out there and know that it'll be there and know that it will be good, is crucial to the business. Downtime, like if your site goes out, this is a complete anomaly at this point. It's like, what? No, you're actually having a maintenance window? This makes no sense to me, right? And the skill set needed, even amongst ops people, becomes more like software system integrators, because you're using third-party SaaS platforms and offerings, and you're integrating it into your delivery pipeline and your product itself. this drives the cost of failure to infinitesimally small. You can rework and have something out and replaced in minutes. We're not talking year, month, week, minutes. It's like, oh, we put something else. Oh, that's wrong. Turn the crank, push the button, revert it back. Okay, what's the exposure? 3 minutes. Okay, our customers were exposed to this error for 3 minutes. You know, you don't even have to do capital planning. Like that is even now, like elastic compute and in storage really help in this, that you don't have to do all this upfront planning and cost. And again, your configuration management and automation tools, CloudFormation, Chef, Puppet, Ansible really make it cheap and easy to remediate things compared to the old world. You don't have to have a human, you don't have a ticket, you have a page. A lot of times these things can be automated rollbacks. So speed is king. So at this point, with all this automation and all of the cost of failure being so low, a lot of a number of people have said, okay, well, test is dead. Famous GTAC talk by Alberto Savoya in 2011 basically said as much. Test is dead, right? So people don't perceive the need for having a customer proxy in engineering because we can ask customers directly. We can observe their behavior, real user monitoring. We can do canary deploys and A/B testing. So we don't need to have that customer in to do that because we can run experiments on that. Everything is automated, right? So what is the QA department doing here? This is what I like to call the automation apocalypse, right? So layered on top of all of that, you have things like machine learning and computer vision, like today are really good enough to handle visual verification tests. Now, this is something when I started I thought would never happen. Like, this is an impossibility. It's like, oh man, you can never solve the off by 1 pixel problem, or if you have dynamic components on your web page, it's like you're always going to need a human for that. Machines can't do that. It's always going to fail. Well, folks, here now, that all happens with regularity. There's a number of products, including the one I'm being hosted by, that are able to help and do this today. For me, that kind of blows my mind, and it's only going to get better in the future. The same thing with like APIs. There's tools out there that you can just run against your Swagger, and it'll generate your base white line coverage. Your happy path coverage for your testing is boom, right there, done. So the time that humans, are responsible for, visual verification and this kind of happy path testing is really nigh, in my opinion. But does that mean everything's dead? That QA really, really, really is dead? No. I think everybody should slow their roll a little bit and see, okay, how does this change? What happens next? So what happens is that this mindset, right, this experimental confirmations bias fighting mindset is still really, really important, right? It's valuable to the business. We might not call it test, we might not call it QA, there might not be a department, but that mindset and kind of the role, I think, is still important. What might we call it? In the past, recently, I've called it QA ops, quality operations. Noah Sussman just this week kind of put out on Twitter, maybe it should be called Square, software quality and reliability, right? Jeff Sussman in a talk that this talk was inspired by on continuous quality called QA a quality advocate, right? So the role is going to maybe have a different name, but there's work that still needs to be done. The first and most obvious one is in infrastructure code, right? So if infrastructure is now code, that code needs to be tested. So how many people do you know that actually do CI on their infrastructure code pipeline, right? So like when your infrastructure, let's say your Puppet script or your CloudFormation revs, that you push out on a side environment something to test that actually works before that's merged in. I've done that, but a lot of people, they just don't. In this kind of big distributed environment, things like performance, because speed matters, security and compliance matter a whole lot more, as you have some of these old world businesses that have big compliance regimes, banks, insurance companies, anything dealing with healthcare, HIPAA, HIPAA and PCI. That as they kind of move into the cloud, that needs to be kind of ported over from kind of these old regimes to new ones. And then, lastly, these kind of complex distributed systems that you're relying on so many external parties playing and dancing together, you can't really model that. So that needs to somehow be verified so you can know what to expect and what kind of resilience you have to build into your product. So for us QA humans, test humans, what does this future look like? Well, you're going to have to code. These are table stakes at this point, right? You don't have to be a complete expert, but you do have to know your way around a keyboard and CLI. That's just the name of the game at this point. You're going to have to be up to speed on what's happening in the arena, because frameworks and tools change every 6 months. There's something new. Maybe you should use it, maybe not. You have to be open to learn and grow at that point. There's still a huge need for good information, and that really comes down to good test design and results analysis, right? So think about it like the intelligence community. You wouldn't want to give raw intel to people to make decisions. It has to be put in context and analysis done of it, before it becomes kind of useful and actionable intel. And then professional skepticism really kind of guards against some of the aforementioned misaligned incentives that I spoke about with development to actually deliver software, and that really kind of can contribute to organizational groupthink. Okay, so think of the U.S. justice system, right? You have DAs and you have defense attorneys, right? Through the advocation of each side in kind of, a semi conflicting manner, do you get to justice? Do you get to truth? So I think the role of questioner, the role of skeptic, going forward is crucial. A little more on infrastructure as code. It's code. It needs to be tested. If it's in a pipeline, you test it. If it's in delivery, you test it. Your code needs to be tested. It actually needs to be tested better than your product code. So the MTTR rules, the mean time to remediation and speed that rules product, that's enabled by being able to reliably and repeatably deploy that code. So if your deployment pipeline is worse off than that, you can't safely deploy your product. So that your pipeline needs to be rock solid so you can trust it. Everybody can trust it. So when a change needs to happen, you can just not think about it, turn the crank, and it goes. But to get to that level of resiliency, you need to test the hell out of that. Software supply chain is, with so many third-party libraries, open source libraries, SaaS platforms integrating into your pipeline and product, you're going to need to have a way to vet those things. things. Component-wise, there's things like SNCC or pieces in Artifactory or Nexus that can help figure out what the dependencies are and when vulnerabilities are injected in and when things will need to change. So really thinking about your software supply chain, all the software and services that you use, and actively managing it is a thing that's needed going forward. So performance-wise, with the tie to customer experience, especially in web and IoT and mobile, which get a little bit trickier because the reliability of a fast pipe or dedicated connection isn't there, is important. So if something messes up, you lose eyeballs, you lose page conversions, that means you lose revenue. So that it's really about money at that point from a front end, but also from an infrastructure standpoint, right? So if infrastructure is code, you don't want to over-instance your infrastructure, right? You want to right-size that so you're paying as you go. You're paying for what you need. Back in the data center days, it was common practice to really kind of scale up that infrastructure for spike, just because it was so hard to add additional capacity when that spike came. With elastic resources, this is a lot easier. But that really kind of puts onus on figuring out, through performance testing and profiling what the right baseline size of that infrastructure is and have it scale in and out. Those inefficiencies can end up costing your business real money. So there's an actual business incentive to perform these acts. Okay, security. I don't know if we need to really talk about this with Equifax or WannaCry or Mirai or name your big nasty exploit that's out there. We need it because if you have a large security failure, especially if you are in a regulated industry, it can kill your business. So there. And second of all, there are types of testing, red team activities, penetration testing that are actually testing, right? So it leverages that kind of same I want to break it skill set and mindset that folks have. So maybe add that tool to your toolbox. Following on that, compliance, a lot more compliance ruled industries are moving to cloud. So you have a lot of privacy concerns, data concerns, right? PCI, HIPAA. And if you're audited, you want to be able to prove that yes, our controls are adequate, right? Otherwise, you can get large fines and you can get sued and again go out of business, right? So testing, that verification in there proves that okay, we did these things correctly and we're covered from that end of things. So, I mean, in testing, I haven't really heard a huge amount of, testing like user intelligence tests or like A/B or like RUM or things like that. So it's really interesting to dig into how many like A/B experiments actually yield actionable data, right? So maybe there's work in there to like make those actual A/B tests more meaningful so you can get meaningful data back to the business. Right, and as well as the analysis of those results. The worst thing that can happen is to say, okay, we're going to test the users and misinterpret that data. So you kind of like hurt the business on two ways. Like you didn't do something up front, deposit, and then you are misunderstanding what the users are actually doing. Now, for me, the nascent field of chaos engineering is really the funnest, most awesome thing to come around. So you may have heard of Netflix Simian Army. Man, that is some good stuff. So basically, that's just breaking production on purpose. Why would we want to do this? Well, it's really that production nowadays is so complex. It's often imitated and can never be duplicated in a lower environment. You can't get all the things that production, a widely complex distributed system has, multi-AZ, multi-region. It's like Netflix can't build Netflix for itself to go test things before it pushes to production. It's as simple as that. And other businesses are going to find that to varying degrees. Like Netflix is the huge case, but other businesses are going to find that, oh, this is actually really, really difficult to stage a whole thing in a non-prod environment. So what do? You have experiments to inject failures into the live running system to prove that your remediation and resiliency is actually up to snuff, right? It's destructive, and you usually kind of try to limit the blast radius of that. But as you get more and more confidence in the resiliency of that system, you can dial that up, taking out whole availability zones, whole regions. Like you could live test, DR or business continuity in the extreme, and at that point that those things actually work because you've done that experiment. So you have the confidence that you're not going to go down. I'd be remiss if I didn't say anything about IoT, because kind of IoT is an outlier for a number of reasons. So that's hardware. So mean time between failure actually becomes a little bit more important because the cost of failure is higher. So after all these years of just dealing with like software and hey, we'll just push it to a cloud. Oh, wait, we have to actually have physical inventory. God forbid you have a write once firmware, and you'd have to actually backship something that you sent to a customer to do to fix a firmware bug. You can't even really rely on these devices being available at any time to do things for updates. So you have to really test that, especially your update procedures in firmware, to make sure that's rock solid so all your other fixes can get to the customer. So, in conclusion, increasing amounts of code in infrastructure and other ops-related domains need to be tested. Wherever they are, their code, it needs to be tested. That kind of adversarial, skeptical, curious, I like to break things mindset is really, really helpful for these tasks to really fight the possibility of groupthink and confirmation bias. And really how this looks in your organization will be determined by the cost of failure in your domain. And that is it. Thank you.
Ed, I just want to thank you so much for a great presentation on the future of QA. If the audience has any questions, you can ask them here, or you can also just DM Ed right on his Twitter handle right here, @EL Rousseau. And if you're interested in the future of QA and the future of DevOps, I encourage you to sign up for Mabel as well, as we're building tools for that audience. Thanks a lot and have a great day.